Following is an introduction to using loops in Python. So let's just start right out. Let's write the code to print the numbers from 1 to 4 on each line below. Simply write print 0, 1, 2, 3, 4, and we get it. So if we can do that, we can go to 10,000, print 5, print 6, print 7. Let's see how we're doing so far. Just a few more to go. 8, 9, 10, just 9,990 more to go. And obviously this isn't going to be a good idea. The only thing that differentiates each of these above is just the number that we put in. Computers are good at doing repetitive calculations, and we can do those with loops. Loops simplify the work for us, and the way that we'll use this is with a so-called for loop. There's for loops and while loops. Here we're just showing for loops. So the syntax is for I in range 10, colon, print I. And if we do this, then we get the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's look at the syntax. We use the keyword for, then we give some variable, it can be any name we want, in is a keyword, range is a function that creates effectively a list for us, and the list will go from, we'll have 10 objects, it will default to start at 0, and because there's 10, it'll stop one short of 10, so it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have the keyword, the colon, and then anything we put inside that's indented as part of the for loop, every time through the loop, we do this code. So the first time through the loop, I is 0, and then we execute all the statements. Then we go back up to the top. Now I will be 1, execute all the statements. Next time, I will be 2, execute all the statements, etc. Range is probably the most common function to use to get the elements to loop over, but it's not strictly necessary. If we have, for example, a list like names equals a list of names Joe, Jane, Dan, Sarah, then we could go for name in names, print name, and we get the list of people. So it's basically just taking this variable, and each time through the loop it takes on a sequential value from the list that we give it. So again, the parts of this are the I, which is the variable, can take anything we want, and it's weird and unexpected for most people that it doesn't start at 1 and go to 10. It starts at 0 and goes to 9. We can put any code in that loop. That includes functions, variables, expressions, math, etc. So here's an example. For the ideal gas law, the pressure is given by P is nRT over V. If we let N be 1, R be 8314, and T be 300, then we can evaluate the pressure for volumes of 2, 3, 4, 5, etc. up to 20. So let's go ahead and run that for I in range 20, and we can go N equals 1, R equals 8314, T equals 300, and P equals N times R times T, and let's let V, we'll call this V, divided by V, and print P, and we get a division by 0, because in this case we're starting at 0 and dividing by 0. So we can change where the range variable starts at if we type 2, 20, and let's also print V just to see it. So V goes from 2 to 19. Oh, if we want to include 20, then we need to stop at 21. Much better. So remember, it stops short of the last element, so we need to go one higher than 20 if we want 20 to be included. Now in this case, it's not a great idea to put all these things inside the loop. We should put them outside of the loop because we don't need to reset them every time the loop is executed, and we get the same result. Now suppose you want V to step by some other quantity. If we want it to step by 2, instead of doing 2, 3, 4, we wanted 2, 4, 6. we could set a step value of 2, and then we get 2, 4, 6, 8. If you change that to 3, it'll step by 3s. If you change that to 0.2, then it complains because you can't step by non-integer values. So the step size needs to be an integer. But you can go backwards. You could go from 20 to 1 by -1, and now it'll go 20 to 2. Again, it stops short of the last values, so 20, 19, 18, etc., and it stops before it gets to 1. And here it's stepping by a size of -1, so we can go backwards. So let's write a function to add all the numbers from 0 to 100. So this is an exercise, and you should pause to think about it and try to work through it, and then we'll come back and work through. So add all the numbers from 0 to 100. Before you start this, you should think about what you would do if you're trying to solve this in your head. If I was solving this in my head, I would think, okay, I start with 0, then I add 1 to it, and my sum is now 1. Now I add 2, and my sum is now 3. Now I add 3, and my sum is now 6. Now I add 4, and my sum is now 10. So I'm holding two things. I'm holding the sum, and I'm holding the next value in the list. And each time, I replace my old sum with my new sum. So let's go ahead and work on this problem. I need a sum, and it starts at 0. And then I'm going to do a loop because I'm incrementing all the numbers. So for I in range 0, 101. And then we can go s equals s plus I, print s. And we get the answer, 50, 50. And notice this syntax, s equals s plus I. Sometimes this can be confusing. How can we have s on both sides of the equation? The computer thinks about it logically. So the first time through the loop, s is 0 and I is 0. So we go 0 plus 0 is 0, and we take that number and store it in the variable s. It doesn't matter if s already exists. Whatever it is, we're resetting it with the value we choose. The next time through the list, s is 0 and I is 1, so the sum is 1, and we take the number 1 and we store it in the variable s, overwriting the old value. Now s is 1 and I is 2, so we have 1 plus 2 is 3. We take the number 3, store it in the value s. And we can see that if we type print s, print I comma s, then we increment I, and every time s starts at 0, then it's 0, then it's 1, then it's 3, 6. You can watch it grow until you get up to the final result of 50, 50. So that's a simple example. We can do nested loops. You can put any code in a for loop, even another loop. So look at the code below. For I in range 3, and then we're going to print I equals the value. And then inside that we have for j in range 4, print j equals value. So we want to predict what this code will output. So go ahead and pause for a minute. Think if you can see what's going to be printed to the screen. Note that every time we go through the top outer loop, so as we go through, when we start, I will be 0, and then we do everything inside that loop, including the full inner loop. So we're going to print I equals 0, and then we do this whole thing. And this is going to go j is 0, prints j is 0, then j is 1, prints j is 1, then j is 2, prints j is 2, then j is 3, prints j is 3. Now we're done with this loop. That means we're done with the outer loop. Then we go up and say I is now 1, and repeat. When we do that, we get the outer loop. I is 0, I is 1, I is 2. And for the inner loop, we get the entire inner loop. J is 0, 1, 2, 3. Now back to the outer. I is 1, then j is 1, 0, 1, 2, 3. Outer, inner, j is 0, 1, 2, 3. So nested loops can be convenient for lots of different kinds of things, creating a multiplication table, creating elements of a two-dimensional matrix, and anything that has two variables, for example, that you want for every value of x, you have a range of values of y. You can make triple nested loops, etc. So let's look at the following example. We have the following function, f of x is x squared minus 3. We can use Newton's method to find x for f of x equals 0. The Newton recurrence formula is given like so. X new is x old minus f of x old over f prime of x old. We solved this in Excel a little while back. And so let's go ahead and look at the solution to this problem in Excel. So here's an example. In a cell we can put a guess, and then in the next cell we write the recurrence formula. So x new, this cell, equals the old cell minus f of x old, which is x squared minus 3, divided by f prime of x old, which is 2 times x old. So we have this cell, and then we drag the corner down, and we can see the result converging to the answer of 1.73205. Now in Excel, the parts are, we have an initial point, we have a recurrence relation, and we have a drag down. In Python, the drag down part is the loop, and the loop surrounds the recurrence relation, and we have an initial condition. So let's go ahead and solve this problem using Python in the simplest way we can. Just like Excel, x is 1, the initial guess. Then we write the recurrence relation, x equals x minus f of x, which was x squared minus 3, divided by f prime of x, which was 2 times x. Now we're going to wrap this. So in Excel we would fill down. In Python we wrap it in a for loop. For I in range, pick a number, 10. And if we like, we can print the progression. And we see that when we start at 1, the first iteration gives us 2, 1.75, etc. So first iteration 2, 1.75, etc. Now again, we're using the same idea of overwriting. We're using a single variable and overwriting it each time. It would be possible to write this as like x old, x new equals x old minus f of x old divided by f prime of x old, and we can print x new. But if we're not careful, then we won't get any results out, because notice that x old never changes. It's always 1, which means every time through the loop x new is only 2. So what we need to do is every time through the loop, when we create a new x new, x old needs to be reset. So we simply write x old equals x new at the bottom, and then it converges nicely. So you can either use a single value that overwrites itself, or split it into new and old and then reset the old at the bottom of the loop. The advantage to this is it lets us compare x old and x new if we want to look at something like defining a convergence criteria. Now note that in this case, I is not being used. We include it just for convenience in defining the loop, but there's nothing that requires I to actually be used inside the statement. That's completely up to us. In Python, a common syntax for doing that would be to use an underscore in that case. So again, you can make the comparison between exactly what we're doing in Excel and Python. We have a cell for the guess, a variable for x. The Newton equation in terms of the x cell, the Newton equation in terms of x. Very similar, Python and Excel. Repeat by filling down, repeat by wrapping in a loop. Okay, let's repeat the first solution using functions for f of x and f prime of x. So this time we can go def f of x, return x squared minus 3, and def f prime of x, return 2 times x. And then if we write our Newton solution, we can write x is 1, x equals x minus f of x divided by f prime of x. We can wrap that in a loop I in range 10, print x. And we get the same result, but this time we're creating explicit functions and then calling those functions in the loop. To get 4 decimal places, suppose we only care about, I don't know, 3 decimal places. We only needed 3 iterations. There's iteration 1, 2, 3. But we didn't know this at the beginning, so we guessed 6, or here we guessed 10. If 10 wasn't enough, then we would do more. This guessing and checking isn't very efficient, so let's modify the code above to do just the right number of iterations. And to use this, we need some measure of the guess. So this is a good spot to see if you can go through and work this problem. And pause. And let's go through the solution. So in this case, we can say, let's go ahead and keep our old solution. And we can write on each loop, this time let's call this x old, x new, x old, x old, x old. And at the end we'll write x old equals x new to replace it. I don't need that step for now. Now between these, we'll just go maybe 100 points. We'll just loop 100 times, but then every time we want to compare the error. So if we write error equals x old minus x new, this is the change in the solution from one step to the next. If we divide that by x new, then it's the relative change. So it's the percent change from one iteration to the next. And if we take the absolute value of that, then we have the magnitude of the change. Now let's say if the error is less than 0.001, then let's break the loop. And each time we'll print x new. Whoops, made an error. NP, not NB. So here we can see that, in fact, again, it took 3 iterations. On the last try, it was already achieved, so it has broken the loop. So break is a keyword statement, a keyword that means if you hit a break statement, it means stop the loop early. So only instead of doing it 100 times, we finished, and let's go ahead and print I, x new. You can see that on iteration 0 we were at 2, iteration 1 we're at 1.75, iteration 2 1.732, and then the final iteration that we go through, we see that in fact we are converged. So this is a way to stop a loop early is with a common break statement. And again, we can combine it with an if statement to say whether or not a measure of our error, in this case the relative error, is less than some predefined tolerance, will break early. So that's a brief introduction to using loops in Python.